You've heard of the hue circle, but have you heard of the hue plane? On this video, user SteveKing6204 said, "Wait, you've never told us about hue planes." I would love to tell you about hue planes. First of all, thanks everybody for all the discussion and comments on this video, where I argued that character-first concepts of color harmony were more logical than hue-first concepts of color harmony. That was a recording of a Zoom lecture I had given last spring, and I never thought uploading it here that it would resonate with so many of you fine folks on YouTube. Awesome. There's so much to follow up on from the comments, and I'm hoping to do some additional follow-up content about character-first harmony and how to apply it. So hang in there. Today, however, we're looking at a basic concept that's fundamental to character-first harmony, and I think to understanding and navigating color in general, and that is the concept of the hue plane. Traditionally, color instruction starts with a circle, which really only demonstrates the relationship of different hues to each other, like which hues are next to each other, red and orange, and which hues are across from each other. But the hue circle is just one loop within a larger space of all possible color perceptions. Let me explain. This particular color circle is also a representation of how the hue circuit, which runs around the edge, can be filled in with grayer and grayer colors until you get perfect neutral at the center, where all hues balance out. But where are the darker colors and where are the lighter colors? Well, we can introduce more hue circles. Here's a hue circle that's darker colors, colors closer to black, and here's one made up of lighter colors, colors closer to white in appearance. And I can sort of stack them. When we go darker to lighter, we start to get a hint here that the colors we perceive don't just make a circle, but a whole three-dimensional solid. You don't have to slice the solid this way. You can also slice the solid this way, up and down. Any vertical slice of the color solid is going to be, by definition, one hue, because we're not going left or right. We're just going up or down. So if we're slicing it vertically, by definition, we're not looking at all of the hues. We're only looking at one hue, and that hue stays constant even as the colors change darker, lighter, grayer, and that's why this is called a plane of constant hue, or a hue plane. Let's look at a page from this vintage Munsell student color set. This is all the variations of red-purple, also known as magenta. Darker colors toward the bottom, lighter colors toward the top, and more vivid colors to the right. Notice how the vivid magenta is sort of in the middle of the value range. Vertically, it's at a 5 out of 8. But if we flip to another page, say green-yellow, you see that the most vivid lime is actually at level 8. This is really a key insight of understanding color. Hue planes for different hues are shaped differently. Some of them point up, some of them point down, because each hue reaches its full vividness at a different lightness level. You should also notice that some hues reach a higher chroma than others. Magenta's hue plane, for example, points out to chroma level 12, whereas blues only gets out to chroma level 8. When trying to name or describe different variations of a single hue, hue planes are invaluable. When naming variations of a single hue, you can broadly divide a hue plane into, say, pale, vivid, muted, and dark. But other descriptive words are possible. For example, the Inter-Society Color Council, in conjunction with the National Bureau of Standards, developed a color naming system in the 20th century, where they divided up hue planes into areas like pale, light, brilliant, strong, vivid, moderate, grayish, dark, deep. And then there's the Japanese practical color coordinate system, which divides up the hue plane this way, with terms like soft, dull, grayish, light grayish, and so on. One thing to note is there are different ways to divide up a hue plane. We've already looked at the Munsell system, which divides up a hue plane by lightness and chroma. Every row going across is equal lightness, and every column going up and down is equal chroma, or distance from gray. But Munsell's lightness chroma grids aren't perfect. One thing they can't tell us is which colors in a hue plane have the same saturation. Saturation is basically how pure a color is, how free from whitishness it is, and as a colored object gets obscured by darkness or turns away from a light source, the purity of its color doesn't change. It just gets darker because there's less light to reflect. So colors can be dark and still very saturated. If I'm trying to calculate how do I get from a color like this down a line of constant saturation to darkness, there aren't actual chips that follow that line, right? I have to kind of step over or step down, and I can only really approximate a line of constant saturation. Digital artists are familiar with saturation, and they're familiar with hue planes like this and this, where lines of constant saturation, or at least saturation relative to the colors available on a computer screen, are lined up like this or like this. There are systems out there that combine these different measures to divide up the hue plane, like Sven Hesselgren. His color atlas uses lines of constant saturation and lines of constant lightness to divide up a hue plane. And then there's the German DIN system, which has lines of constant saturation kind of like in straight grids like this. And if lightness, chroma, and saturation aren't enough to confuse you, there are other ideas out there about how to divide up a hue plane. One recent proposal, which I like, is by Roy Burns, who says that you can divide up a hue plane into lines of constant vividness, or distance from black, and lines of constant depth, or distance from white. As a kind of a side note, not all color spaces have built-in hue planes. Here's what I mean. If you take RGB, which is kind of arranged like a cube, right? Because on a computer screen, you've got red pixels, you've got blue pixels, which are like a deep blue violet, and you've got green pixels. And so that creates this sort of cube-like lattice of possible colors. As you can see, if I'm looking for planes of constant hue in here, I'm not going to find them. This plane, for example, has like reds, dark reds, purples, blues. Or if I flip it this way, I get like greens, limes, yellows, oranges, reds, browns. While all the colors are still here, they're not arranged into hue planes. So no matter how you decide to map out or name the zones of your hue plane, I believe that the concept of a hue plane is fundamental to understanding how to navigate color. I think it's just as fundamental as the hue circle. You can't really understand and navigate color without both the horizontal slice and the vertical slice of all the possible colors